Hey team, it's Mr. Z, and today we're going to continue after getting started in our last video. If you haven't watched yet, go a lesson back in the past, watch it, and come back. So let's go ahead and talk about creating functions of higher degree. We've been dealing with a lot of degree 2. Let's continue to explore what that kind of means. So this first paragraph is just kind of summarizing. Recall, you can dilate a function vertically. This is a key part in some of the syntax we're using. Just kind of keep that in mind. And it's saying that if you multiply a function by a constant, just remember, is a number. So for example, the function is f of x is equal to x, aka pretty much the most simple function out there. So let's examine what happens. Basically, they're saying a is that number that you can plug in. It represents a vertical dilation. So you can either have pretty much two situations. You can have, for example, where it's 2x, where it's going to be a vertical stretch. You're doubling it. So it's going to be much bigger. Or you can take a part of it. For example, 1/2. That can go ahead and be another a vertical, but this time it's going to be shrinking. Okay, let's go ahead and continue. So what happens when you transform a function by an a value that is not a constant, aka multiplying it by something that's not just a number? Suppose the function f of x is equal to x plus 3 is dilated by x. They're saying the function, this rule, is dilated by x. X is being dilated. What is dilated? Multiplication. Remember that. Dilation, multiplication. Kind of like how you had to remember that parentheses meant multiplying. Same deal. So, this would mean that the y value of every point on the line, y equals x plus 3, is dilated according to its corresponding x value. Right now, this isn't going to necessarily make sense until the final moments of this exercise. So, hold on with me and let's just keep going. All right, this graph shows the function f of x is equal to x plus 3. Notice how it's a line. Now, depending on your level of proficiency with slope-intercept form, maybe you might recall that f of x is equal to mx plus b. Remember, f of x is the same thing as saying y is equal to mx plus b. They both represent the output. M is Monsieur, a French word for slope. B is going to be the y-intercept of this function. So I could know that a positive slope, when m is a positive number, it's going to look like so. And when m is a negative number, it's going to look like so. For example, I see in this situation that the slope of this function is a positive 1. So in my mind's eye, I would know that based on its form, it's going to look like this, and it's going to have a y-intercept of 0, 3. Okay, let's actually get to the problem. So I'm going to take several points and multiply it by the corresponding x value. 2 points have been dilated. What is happening? 0, 3 becomes the point 0, 3 times 0. And likewise, negative 1, 2 becomes the point negative 1, negative 2. So, remember, this is where we're starting, the 0, the input. The input is 0. X is 0. So, add 0 in this rule. The rule is f of x is equal to x plus 3. And since I want x to be 0, it's going to become the following equation. And it's going to say the input 0 results in the output 3. Hence why the point x, f of x This is a fancy way of saying x comma y is going to be 0, 3. This is why this point is where it's at. It's why it's the y-intercept algebraically. Now what we're doing is we are taking our equation and multiplying it by x. We are dilating it by x. So what I need to do is take x and multiply it by my rule. In this situation, what is the value of x? It is 0. And I'm going to be multiplying it by the f of 0. Well, what is the output when the input is 0? So this turns into 0 times 3, which is 0. My input was still 0. My output is 0. Hence why it changed. Okay, we're going to do this again for the point they provided, and then we're going to actually take an attempt to do it. I'm going to take this next point, green, -1, 2. Again, the input was decided to be -1. When I plug it into the equation, it turns into -1 plus 3. That is going to go ahead and turn to be 2, resulting in x comma y. The coordinate point is going to be -1, 2, aka why it's there to begin with. Now, I need to take my rule, x, and multiply it by f of x. What is happening is I am taking my input, which was -1, and I am multiplying it by the output of that -1. That is really just saying -1 times 2, which is -2. Hence why the new point is -1, -2. It changed. It is now here. Okay, so do we understand how the red points are the result of multiplying by x?